Hello, welcome to the episode of Demola, and today we're going to be covering lipids. It's finally time to close that chapter on topic one, so let's get straight into it.
Okay, so our fats are going to exist in the form of a triglyceride, yeah? And the triglyceride, you need to know the components that make it up, yeah? So we're going to have one glycerol, and we're also going to have three fatty acids. So you can see here, we've done the times three, really important to know that there's three fatty acids. And what I've shown below is just the final product, right? So you have your glycerol plus the fatty acids. That's your chemical equation. What it's going to form is going to be this molecule. So this here, I'm going to write underneath it in yellow. This is a triglyceride, yeah? And when we're forming bonds, we're going to form what we call ester bonds. Really important that you know this, ester bonds. And your ester bonds are going to form between, if we go back here, your alcohol group and the carboxyl group, yeah? They form between both of those to form that ester bond, and then you have the rest of the fatty acid chain there. And as you can see, we formed 1, 2, 3 bonds, hence, we're going to also release free water. As we mentioned in the carbohydrates video, this is what we call a condensation reaction, the formation of a chemical bond resulting in the release of water, yeah? And what you should also know is that fatty acid chains can be different lengths, impact its properties. Imagine, if you have a longer chain, we're going to need more energy to break that up. Hence, that triglyceride or that fat is more likely to have a higher melting point. Also, another important thing to mention is that all of these triglycerides are non-polar and hydrophobic, yeah? So you tend to get these terms fat soluble and water soluble. That's kind of where this comes from. So non-polar hydrophobic molecules when we're talking about triglycerides. Let's keep it moving. So I want you to introduce the idea about differences in the carbon chain of your fatty acids, yeah? And that kind of brings us into saturated versus unsaturated. Again, I'm going to just mention it one more time. A longer chain is going to have a higher melting point. That's something important to know. Now, let's look at this. Saturated means that there are no carbon-to-carbon double bonds, yeah? That means that we're not going to create kinks or like these bends in the chain. If it's saturated, kind of what we're getting at is that the maximum number of hydrogen atoms are in it, and it's going to have a higher melting point because the intermolecular forces are going to be stronger. If you think to chemistry knowledge, if you do chemistry, it allows it to be more flat, right? Because there's not a bend. So that means that your intermolecular forces can form a bit more easily. We have more intermolecular forces. Let's go back to the definition. You need more energy to break it up. Cool. I also wanted to mention that these saturated fatty acids tend to be fats. So something like butter, for example, would tend to have more saturated fats, yeah? Because it's got a higher melting point. Cool. Let's keep it pushing. And I've also just mentioned unbunched linear chain, and I've drawn it both in your displayed and your skeletal formula. You'll know about those if you do chemistry. I would say whenever you're answering a question in biology, this tends to be okay if they're asking you. So you can normally put it in skeletal. I think it's a bit easier. But if you are not aware of skeletal, stick with displayed. Yeah? So that's kind of for the people that do A-level chemistry. Now, unsaturated means that we don't have the maximum number of hydrogens. So we're the presence of these carbon-to-carbon double bonds, as we've shown in the diagram below. Now, kinks. Very important to know, this is what we call a kink. I'm going to circle it in blue. Let's do that. So, this is what we call a kink, a bend in your fatty acid chain, yeah? That's created by the double bond. Because we have those kinks, it means that your fatty acid chains are less likely to sit on top of each other flat. Hence, we're going to have a lower melting point because there's weaker intermolecular forces. So these tend to more be like oils, for example. Monounsaturated just means we have one carbon-to-carbon double bond. Polyunsaturated means we have more than one. And I just wanted to mention this thing at the end, that triglycerides have a bunch of different functions: energy storage, insulation, buoyancy, protection. I don't think it's too relevant, rarely ever asked, but it's just nice to know. No, nice addition. And just something that I think is a bit important to mention, because whenever we're talking about this topic, we're always trying to relate it back to diet and health, right? Cholesterol, HDLs, and LDLs. Let's start to talk about it. So cholesterol is a fat, right? Very important fat in the body, required for your cell membranes. We'll talk about that in topic 2. Required for some steroid hormones specifically. That comes a bit later, more in your A2. Vitamin D, bile. These are just good things to know about uses of cholesterol if they're asking you a question. I would typically stick to cell membranes because that's the one that you're going to talk about more in your specification. Now, your cholesterol is going to be transported in lipoproteins, yeah? Make sure that you remember lipoproteins, yeah? Your lipoproteins, they're the structure made up of lipids and proteins. We're going to talk about it a bit more in topic 2 when we get to cell membranes, yeah? But just know that these lipoproteins, they tend to transport cholesterol and triglycerides. And the only reason we need to mention it is because we have bad cholesterol, we've got good cholesterol. Yeah. So your bad cholesterol, your low density lipoproteins, LDLs. So these are going to carry cholesterol from the liver to the tissues. So imagine they're taking cholesterol that's already in the liver. They want to get that towards the tissue. So it needs to travel through the bloodstream to get that. Yeah. If we have excessive LDLs in the bloodstream, that cholesterol can get deposited on artery walls. Think about it. You start to form your atheroma. Yeah, think back to atherosclerosis. Start to form the atheroma. You get the process of atherosclerosis happen. You're increasing your risk of cardiovascular disease. That's why it's so important not to have too much cholesterol. It's important not to have too much saturated fats because those are going to be the ones carried in your LDLs. So just be aware of those points. Yeah. I also thought it was good to mention, again, we're going to lead more into it in topic 2, but your LDLs tend to bind to LDL receptors, which are found in cell membrane. And that's kind of how you start to deposit the cholesterol into the cell. Cool. Let's talk about good cholesterol now. Your good cholesterol, or your high density lipoproteins, yeah, they want to carry cholesterol away from the tissues. So they take it from the tissues, they transport it through the bloodstream to get it to the liver. Now, the liver, this organ is so good at breaking stuff down. Yeah. So it's going to remove excessive cholesterol from the arterioles because if you think about it, the HDL, it sees the cholesterol in the bloodstream or in the tissues, it takes it back to the liver. Yeah. So that means you have less risk of forming atheromas. You've got less risk of atherosclerosis, less risk of cardiovascular disease. Cool. And I just thought it was important to mention saturated fats, LDLs, unsaturated, HDLs. And really, whenever you're answering questions, you want to think about HDL to LDL ratio. Yeah, you want a high HDL to LDL ratio. That kind of indicates better health. So just be aware of that as well. Okay, so for today, we're just gonna have one question, multiple parts. Yeah. So we've got a graph here. Data questions are so hard. Yeah, but have a look at this. Try to use the graph to answer that part 1. I'll quickly just zoom in a bit so you can see a bit better. So that's your graph. You can see here part 1, part 2, and part 3. So pause the video, have a go, and we'll get into the answers. Okay, time to get into the answers. So if we focus on part 1 first, here's your mark scheme. Yeah. And what I'm really going to do is I want to show you the kind of process to how you would get that. So let's look here. Now, the question is just asked, describe the overall changes that have happened. I'm looking at the changes overall from the start in, I think that's 1960, to the end, I'm assuming 1990. Yeah? Cool. Let's just highlight the graphs. Let's look. We're looking at high blood pressure first. Yeah? When we look at that graph, this one at the top, what's happening? Well, from the beginning here to the end here, it's gone down. Yeah? All I have to say there, blood pressure is decreased. Let's go to the next one. High blood cholesterol. Let's put this in green. So high blood cholesterol. Let's look at this one. You can see as well, from the beginning, it's up here. At the end, it's here. It's gone down. Yeah? Second marking point, cholesterol has gone down. Or the individuals with high blood cholesterol has gone down. Yeah? Let's look at obesity, the last one. Let me just get the highlighter out again. Yeah, we're looking at the last one, obesity. This line here. We can actually see this time has gone up. Yeah? Obesity has gone up. So those are your points. Yeah? High blood pressure, or the risk due to high blood pressure has fallen. Risk due to high cholesterol has fallen. Risk due to obesity has risen. Another thing that you can say, this is a really good one to say, lowest to highest. You can see here, initially at the start, obesity is the lowest risk factor. At the end, it's the highest. Another thing to mention. Literally, whenever you're getting a question that says using the information in the graph, it's easy to answer because you literally do just have to say what's happening in the graph. Don't try and make things up. Don't use your previous knowledge. Just say what's going on. Cool. Another thing that's really good to do, I would just do a calculation. Like, you could do percentage change, for example. So like at the beginning here, obesity risk is, let's test ourselves. Obesity risk is maybe like 11% there. And then here, it's looking like, if I just get this correct for you guys, that's looking more like 24%. So you can say that, for example, there's been I believe that was 13% increase or something in the risk. 10.5% increase in obesity. Ignore everything I just said. It's 10.5. That's what the mark scheme said. But yeah, I think mentioning something like that is also really easy to do. Yeah? Cool. For part 2, Literally, these are things that you just need to know. Yeah. In terms of risk awareness, a lot of the time, because of like public health campaigns, more information readily available online, people are going to be eating less bad foods. So less foods with high saturated fats, less foods with high cholesterol. Yeah. People are more aware of the risks. These are easy things to just remember and say in the exam. Yeah. So if you look at this list, just memorize those. People are going to be doing these more because of there's more being awareness of cholesterol being a risk factor for cardiovascular disease. Then finally, risk of CVD, cannot emphasize this enough. You just need to know them. Yeah, you just need to know them. Being male, older age, lack of exercise, smoking, genetics, high alcohol, high salt, high saturated fats, stress, diabetes. Literally, memorize like 3 or 4 of them. You'll be able to mention them in the exam. That's how you'll approach a question like that. Okay, a bit of a short and a sweet one today. A-star tip time. So, remember the basics, yeah? The structure of a triglyceride, the structure of glycerol, the structure of a fatty acid, yeah? Just remember those things. Very easy to remember, in my opinion. You don't want to lose marks for that in exam. Cool. Know the difference between a saturated and unsaturated fatty acids. So saturated don't have the carbon to carbon double bond. Unsaturated do. Just remember things like that, yeah? Functions and features, I'll always stress it. Remember the feature and then say why that feature occurs. Yeah. So like for example, saturated fats having a higher melting point. Remember that's because of the lack of kinks, the lack of bends, so we can form stronger intermolecular forces. More energy is required to break them. That whole thought process, you just need to remember something like that so that you can mention it in the exam. Again, when we're talking about topic 1, cardiovascular disease, they know that content-wise, this is easier content compared to the rest of the course. So a lot of the questions that they're going to ask you are going to be data questions like we did, yeah? So make sure that you practice those data questions, you know how to approach them, because it's really, really important when it comes to this topic. Now, things that we don't do, don't confuse it with carbohydrates. Because this is at the very start of the course, there's a lot more to remember when it comes to biology, yeah? Don't end up confusing ester bonds with glycosidic bonds or ester bonds with peptide bonds. It is easier to do than you may think. Cool. Always make sure you're linking back to cardiovascular disease, especially with SNAB. I know that this can be used for like AQA and OCR as well, but biology examiners tend to want you to think holistically. Yeah, so don't get caught too much up in this is cholesterol. Get more thinking about cholesterol is this, which it increases the risk of this cardiovascular disease or something like that. HDLs, LDLs, just don't mix it up. Doesn't really happen too much, but I just remember H for healthy, so HDLs are good. And then data questions, just make sure you don't misinterpret things or read the data wrong. Yeah? Cool. Thank you so much for listening to the video. I hope it's been really, really helpful. Please subscribe if you're new. Follow us on the Instagram and the TikTok, both at A-star demola. Like the video, leave a comment below if you have any questions, and I'll catch you in the next one. Bye for now.